Hey guys, welcome back. This is our 7th video, and there's going to be two problems on this video just because one of them literally takes less than a minute to do. And so I'm going to do a square problem that has to do with the perimeter changing, and I'm going to do a ladder problem, which is equivalent to some video that we did in the past, which I believe is video 3. Okay, so let's get to it. Each side of a square is increasing at a rate of 3 centimeters per second. Okay, so each side is increasing at a rate of 3 centimeters per second. How fast is the perimeter changing? So we know that the formula for the perimeter of a square is 4 times side because there's 4. 4 times side because there's 4 sides. So s plus s plus s plus s. The derivative of 1p is just 1, but because it's a letter other than t, you got to do dp dt. The derivative of 4s is just 4, but because it's a letter other than t, we have to do d the letter dt. So that's 4 ds dt. And now all we got to do is plug in. They're asking you how fast is the perimeter changing, so they're looking for this here, okay, dp dt. I know 4 is a constant. They told me in the stem of the problem that ds dt is 3, and therefore it's 12 centimeters per second, okay? So if I went too fast, just pause the video, reread the problem, and do that with all my videos. Okay, next. A ladder is 10 meters long. Okay, so let's do this. Let's do this here. So this ladder is going to be 10 meters long. It says its top is slipping down along a vertical wall while its base is being pulled away from the base of the wall at a speed of 1/4 meters per second. So what I'm going to do first is I'm going to call this person here A, this person here B, and this person here C. Therefore, dB per dt, dB dt, is equal to 1/4 meters per second. Okay, so the wall, it's being pulled away at 1/4 meters per second. Now, this, please remind yourself, is positive because you're moving to the right. How fast is the top of the ladder slipping down? So I'm looking for dA dt. And when it is 6 meters above the ground, so this will be 6. The ladder is 10 meters, and that's never going to change. So if you guys remember special triangles like 3, 4, 5, this is a multiple. It's 6, 8, 10. So therefore, you can use a squared plus b squared equals c squared to solve, or you could just say this is 8, okay? So let's do this. So we got a squared plus b squared equals c squared. The derivative of a squared is 2a, but because the letter is other than t, you got to do d the letter dt, and the same thing for b squared, and the same thing for c squared. Now, to reduce, you can cross off all the 2's. Furthermore, okay, so before I just start going really quickly, a is 6, dA dt is what I'm looking for. B is 8, dB dt is 1/4. C is 10. Now, if you remember from the other video, this wall, let me use black, this wall, it's going to be shrinking in size because the ladder is slipping down. So that's changing. That's why we have dA dt. This base is actually going to be getting longer because it's slipping down and making this ladder now look like this, okay, until the ladder gets all the way towards the floor, right? So that's changing. But this ladder itself will never change in size, and therefore it's 0, okay? So I hope that makes sense. So 6 dA dt plus 8 times a fourth is 2 equals 0. Subtract 2, divide by 6, and you get negative 1/3. Okay, so I need to erase some of this up here so we can have a place to write. So it's going to be dA dt is going to be negative 1/3 okay? And that's going to be meters per second. And you can actually just say it says how fast is the top of the ladder slipping. Slipping means negative, okay? So it is slipping at 1/3 meter per second, or, well, that's basically it. So the negative represents the slipping. And that's how you do this problem.